In section 6 of chapter 1, we're going to take a look at first-degree equations. Now, the degree of a term, we said, was what exponent it had on the variable, and for these, there is apparently no exponent, but there is a 1 there. So these are first-degree equations. Now, later we're going to do second-degree equations, and we have x to the second. And then another kind that we're going to do later is radical equations, in which somewhere within the equation there is a radical sign. And another thing we might point out, these are equations because of the equal signs. Without an equal sign, something is a mathematical expression, but with the equal sign, it converts it to an equation. Now, mathematical expressions we want to simplify, and mathematical equations we want to solve. So that's what we're going to do, and when we do solve it, that is considered a solution. And to give you a quick visual of what we're going to do when we deal with equations, imagine we have a scale here with a fulcrum in the middle, and it's balanced. So this means the weight on one side is the same as the weight on the other. Now, what we do as we solve an equation is we take some of the weight off of one side. Now notice this is not going to balance anymore, but if we take that same weight off of the other side, it balances. It's not the same equation, but what we did to one side we did to the other, and it still balances. And if we take off a little bit more from both sides, we now have a very small bit on this side and that same small bit on the other side. And what we're hoping is that on this side, let's say this would be an x, and then on this side now we end up with a 3. So from a complex situation that balanced, we did mathematical things equal on both sides, so eventually we get to a value of a positive letter. A positive x equals a value. That is solving an equation. Now, in this particular equation here, if we looked at it for a while, we could try various values for the letter x. And we might try a 2 there. 2 times 2 is 4, plus 1 is 5. That doesn't work. And then eventually we try a 9. 2 times 9 is 18, plus 1 is 19. Ah, then it's true. So we say then here x would equal 9. But we're going to use mathematical properties to solve equations. And one of them is if we add something to one side and we add it to another, we're allowed to do that. If we subtract something from one side and subtract it from the other, we're allowed to do that. And then later we can multiply something or divide something. As long as we do the same thing to both sides, we're whittling it down until finally we get something like this. So let's look at some real... Now, if you've taken another course, of course, you're way beyond this, but just as a review, we want to isolate on one side the x's. So we want to get rid of that negative 3. Well, to get rid of the negative 3, we're going to add 3 to this side, add 3 to that side. We're doing the same to both sides. So now we get 5x equals 15. So we've isolated the x's on this side, and we have a number on that side. Now, what do we do to get x by itself? Well, remember, this is 5 times x. Well, if we divide this side by 5 and divide this side by 5, here the 5's cancel out and we get x equals 3. And that is our solution. And if we put the 3 there, 5 times 3 is 15, minus 3 is 12, it checks. Now, we can use what the book is describing as well. There's our equation. And one of the rules is to get rid of parentheses or grouping symbols. So we do that by taking the 3 that's in front of the parentheses and distributing that. And taking the 2 and distributing that and being careful of our signs. When we do that, we see we have now like terms. A 2k and a 3k give us a 5k and negative 12, and a 2k, negative 6. Now, when we have something like this, 5k minus 12 equals 2k minus 6. Again, we want to get all the k's on one side and all the numbers on the other. So, to get the 2k away from this side, we're going to subtract 2k, and we're going to subtract 2k there. Now this gives us 3k minus 12 equals now a negative 6. Now to get rid of the negative 12, we're going to add 12 to this side and 12 to this side. So this then gives us 3k equals, that's a 12 here, a positive 6, and I don't need to write the positive sign. Now, to get rid of the 3 that's with the k, by the way, you recall this is the numerical coefficient of the variable. That's usually what we divide by. We get k equals 2. And it's laid out quite well. Now in example 3, they give us this particular equation. Assume that the equation remains valid. Use a calculator to determine when 44% of households will own an IRA. So our x, we don't know. That will be our time value. But we're going to substitute for y with 0.44 as we convert percent to decimal. So that's what they did. They put the 0.44 here. I would have put that in a parenthesis myself here. And the first thing we do is clear this parenthesis, and we get this over here, this minus this. And then we're going to use another technique. When we have a negative value, let's say on this side, we could move it to the other side, is what they're doing there. And then eventually, once we get all of our terms over to this side, and then divide both sides by this, that's where they get this long thing. Put all of that into our calculator, and it will be approximately 2015 when we expect 44% of our households will own an IRA. In example 4, we're using another common procedural step when we have equations with fractions now, is to clear the fractions by multiplying each term by the lowest common denominator. Now, if you were going to add these up, you'd have to make all of these equivalent fractions, and the denominators would all have to be the same. Well, what would we have to multiply? Well, what would be our common denominator first? Well, we have a 10, a 5, a 15, and a 20. And I see the answer down below, but I'm trying to brainstorm how we would do this. And you might say, well, 20. Now the 5 and the 10 would go into 20, but not the 15. How about if we made it 40? No. Again, these would go, but the 15 wouldn't. How about 60? Yes, 60 would be it. So we're going to multiply each term in our equation, and there are terms, recall, are separated by either a plus or a minus sign. So there are 4 terms here. We're going to multiply each term by 60. Now, by multiplying every term by the lowest common denominator, we can simplify and get rid of all our fractions here. 10 will go into this once, 10 will go into this 6 times. 15 goes into 15 once, 15 goes into 60 4 times. 20 goes into 20 once, 20 goes into 60 3 times. 5 goes into 5 once, 5 goes into 60 12 times. Now notice all of our denominators are ones now. We've gotten rid of our fractions. So now we rewrite our equation multiplying through. 6 times r is 6r. A negative 4 times 2 is a negative 8. This is not negative, so this is 3 times 3r is 9r. And this is a negative 12. Now that technique of moving a term from one side to the other, which we call transposition, say we transpose something from one side to the other, it just changes its sign. So here we're subtracting 6r. Well, we're subtracting 6r. So this on this side becomes a negative 6r, and we get a 3r. Now we're going to add a negative to a negative 12, a positive 12. So a positive, this negative 12 becomes a positive 12. This gives us a negative, no, a positive 4. Now we divide both sides by 3, and we get r equals 4/3. So they're doing it a slightly different way. I like the idea of putting the least common denominator by each term already, in this step in a sense. Another technique that is sometimes used here is they'll put a big parenthesis or brackets and then put the 60 out there. You're going to multiply everything by 60. I like to see it this way. Okay. Now in example 5, as we look at our denominators here, our lowest common denominator is actually this. It includes the 3 here, and then also the k plus 2, and this has both. So I'm going to use this other technique in which we will multiply each of our terms. This is 1 term. This is 2 terms. This is a 3rd term by this. Now notice, when you multiply this by this, all of this cancels out, and we end up with a 4 here. Now when you notice, I've changed the position of my negative sign. I like it up there. So I made this plus. So again, when we multiply this by this term, all of this cancels out, and we get a negative k. Now, when we multiply this by the 3 here, the 3 cancels out, but we're left with this, that we now have to multiply 5 by k plus 2. So this is 5k plus 10. And this is where we are over here. Now again, we want our k's to be positive if we can. As we bring this negative k over to this side, it becomes a positive k, and this gives us 6k. As we bring our positive 10 over to this side, it becomes a negative 10. Negative 10 plus 4 is negative 6. Now to solve for a positive k, we're going to divide by 6. And here we divide by 6. So we get k equals a negative 1. And you need to be very careful of the signs as you do things and check your work. Now in example 6, we have this as our example. Notice our denominator is the same on both sides. So to get rid of it, we're going to multiply by this common denominator. When we multiply this by this cancels out. When we multiply this term by this cancels out. So we're just left with 3x minus 4 equals x. So I'm going to take my x to this side as a negative x. 3 minus x gives me 2x. I'm going to take this term to the other side, and there it becomes a positive 4. Divide both sides by 2. I get x equals 2. Now, an interesting thing happens here. If I put 2 into the original equation, notice what happens. I get 2 minus 2. I get this numerator divided by 0, and this numerator divided by 0. In our mathematical system, this is not defined. So, in a sense, 2 cannot be an answer to this. So we say when something like this happens, this is the challenge. There is no solution to this equation because the answer we got cannot be an answer. We call this an extraneous solution. When we get an extraneous solution, such as is illustrated here, there is no solution. Now they've used up all the area. I like to do things over on the side. So here's our example. First thing I'm going to do is distribute the 3 to get rid of the parentheses. And when I do that, I get this. So now I don't have grouping symbols. But I want to solve for this x. This x here. And notice on this side of the equation there's an x there as well. Well, the first thing I do, and I'm going to put all of the x's on one side. So there's a 4x here. So I have a 3ax, that's this term. I'm going to bring this over as a negative 4x from the other side. Now I have all the x's on one side, I got to get rid of these. On this side, this becomes a positive 15a, and this becomes a negative 4b, and then there was a negative 2 there. Okay. Now, since I have an x in this term and an x in this term, how do I get the x's out? Well, I factor out that common x. And I now get 3a minus 4, just factoring out that x from each of these terms, and then that equals what I have here. And it's written out there too, so we don't need to confuse it. So now, how do I get the x by itself? Well, I divide this 3a minus 4 on both sides, 3a minus 4. Now I don't need parentheses, and I don't need it here either. But since I'm going to cancel out this factor, I have it on this side. So what does x equal? Well, x equals this, which is what we have nicely over there. So, reviewing this quickly, we had an equation. We want to solve for the x. Well, the x was on two sides. I got it all, the x's over to one side. Then I factored the x out of there. I did it a little differently, but that's still the same. And then I divided both sides by this, and that gave me my solution. Now we're going to get into what are called absolute value equations. When we see something between absolute signs, we're saying we know that the absolute value of anything is a positive value, 4 in this case. But if we had a negative 4 in there, the absolute value of that negative 4 would have been 4. So what was there originally? Was it a 4 or a negative 4? Well, we don't know because it's an x. It could have been a 4 or it could have been a negative 4. So when we solve absolute value equations, we always write it out this way. Again, in your homework log, you're going to write this, and then the protocol to do it is to remove the absolute signs and just write it this way. Or remove the absolute signs and write it this way. That is, could have been a negative. Now, in example 9, where we have a little bit more than just a letter, the way to do it, the first time you do it, just remove the absolute signs, and that's one way to write it. And what I say, for the next time, just go or, remove the absolute signs, p minus 4 equals a negative 2. So write it just this way the first time. Second time, or p minus 4, and then here you're going to make that a negative 2. Okay? That we have it set up this way, what will this become? Well, we just transpose this. On the other side, it becomes a positive 4. So one value of p is 6. Or transpose this negative 4 to the other side, it becomes a positive 4. And we get p equals 2. Okay? Now they're making it a little more confusing than perhaps it should be, but ideally that might be the way to do it, theoretically, but let's keep it simple. Now in example 10, where we have on both sides of the equation absolute signs, the protocol for doing this would be remove the absolute signs and just solve it regularly. And let's do this one. So we're going to bring the m over as a negative m. That gives us 3m. Bring the negative 3 over as a positive 3, gives us a 9. Divide both sides by 3. There is one solution. Now, the way we do it the second time is we remove the absolute value. That's what they've done here. But when we remove the absolute value on this side, we put it in parentheses. And we put a negative out in front. Now we have to remove the parentheses by distributing that negative. That is, changing both of these signs. Here it was a positive. It's going to become a negative. Here it was a positive. It's going to become a negative. And now we just solve that. A negative m to this side makes it a positive m. 4m plus 1m is 5m. Getting ahead of myself. Bring that negative 3 over. On this side becomes a positive 3. Negative 6 plus 3, negative 3. Divide both sides by 5. There is my other answer. So again, the strategy, remove the absolute signs and solve it regularly. In this case, remove the absolute sign, put this in a parenthesis, but a negative in front of it. Clear the parenthesis by changing both signs, and then solving. Now, equations wouldn't be fulfilled in a sense unless we had some kind of applications for them. And here they're giving us a little scenario of what to do when you have a word problem. And I'll just review it, and you can pause and read it as you do your study in your textbook. And the key word first is to read it carefully, focusing on trying to understand what they're asking. And read it again. Next, identify an unknown. If they want to know what miles are, you could use the letter M. Now you can always use the letter X. That's often used. We would never use the letter O because it looks like a 0. And the letter S, that's not used too often either, although it does. I always change it to cursive because this looks like a 5 a little bit. If it's force, you might use an F. If it's time, use a T. If it's rate, you might want to use an R. If it's distance, you might want to use a D. And if Bert does something, or Betty, use a B. Harvey or height, use an H. So this is the unknown. You are identifying the unknown. And then you want to formulate from the information given you in the original example an equation of some type. Often useful too is to draw a sketch, make a chart showing the relationship of what you have. So visualizing what you're going to look for. For instance, if you had a rectangle, you could make a rectangle. If you had a triangle, you can make a triangle. Now, chances are the sizes may not be proportional to what they're asking, but at least you have a place to put measurements. That this would be a length, and then this would be a width. And then in a triangle, this is the height. And this line here is the base. So you have a visual of what you're working with. Or if it's distance, you might say, well, it's so much this way, and they're going that way, and then others are going this way, and then this one is doing 30 miles per hour, and this one's doing 40 miles per hour, they're going to be 150 miles apart, as you start putting material. And then, of course, you'll see the various tables where they have rate times time equals distance. And you're filling things in. Again, they don't have to be too fancy, and they are meant to be an aid to your solving it. Then, once you've solved your equation, you see, does your answer make sense? One of the problems we had in my other class was when we solved something, we ended up with time. Time was 2 hours. But they wanted distance, and you had to know that distance equals rate times time. Well, if they are going 40 miles per hour, and it's 2 hours, then your distance is 80. So, for instance, when you do your answer statement, 2 is not the answer, 80, because they're looking for distance. Okay, and then finally, of course, you check it. Now, for the example 11, deals with finance, we have someone who has $1,500 to invest. She plans to invest part of the money in tax-free bonds at 5% interest, and the remainder in taxable bonds at 8%. And she wants to earn this much per year in interest from the investments. So, starting us off, and this is all on the next page, but I'll give it my shot here. Interest equals principal times the rate times the time, or interest equals PRT. But we actually have 2 parts to this, because the principal is going to be divided into 2 parts. And how can I divide $15,000 into 2 parts that I don't know how much they are? Well, that's the marvel of algebra. I'm going to say that this part is P. Again, we don't know how much of that 15,000 that's going to be, but the other part would be the 15,000 minus P. I have divided that 15,000 into 2 parts, and the algebra is going to do all of its magic. So, one investment, and let's see, we want to have 5%. So we're going to take 5% of this first part. So rate times percent times time. Now time is just 1 year, so we don't need anything else there. And we're going to take this other investment, 0.08 times 15,000 minus P. See, this is rate times principal. Rate times principal, that's what interest is. And it's going to give me 1020 at the end of 1 year. So I want to know how much each part. So what I would do here is I would get rid of my decimals, so I don't have to worry about decimals anymore. That's the way to get rid of fractions. We're going to multiply this term by 100. I got rid of my decimals. This term by 100. Got rid of my decimals. This is all one term, and I had to add 2 zeros here, so I get rid of those decimals too. So now I rewrite my equation. So I get 5p, then 8 times 15,000 gives me 120,000. 8 times a negative p gives me a negative 8p equals that. Now I'm going to group like terms, And I get on this side then a negative 3p. I'm going to subtract this from both sides, and that will give me a negative 18,000. I'm going to divide both sides by a negative 3. I get p equals 6,000. Now I go up here, and what is p? Well, p is 6,000. And 15,000 minus p, which is 6,000, is going to be 9,000. And that's how I solved this example using these steps and then carefully writing it out. Now let's look at what the book says. Okay, step 1 we did, step 2, step 3, 4, they made a little chart. Now instead of using the letter P for principal, they used X, which can be used. And when they solved it, they ended up with, and notice they kept the decimals, which you can do. I don't like that, but you can also. This is 6,000. So the other was 9,000. And we did it my way. All right, let's go on to number 12 and study it for a moment and see what we need. So again, they are starting us off with some challenging ones here. We have 2 digital music streaming services, and it says that Spotify acquired in 7 business quarters, and a quarter is a 3-month period, the same number of users as Rhapsody acquired in 11 years. So Rhapsody was doing a lot slower than Spotify. Spotify's average rate of user acquisition per quarter was 120,000 more than Rhapsody's average rate per quarter. Okay. Find the average rate of user acquisition per quarter for each company. So we'll follow this. We must find Spotify's user acquisition rate and Rhapsody's user rate. So let X represent Rhapsody's rate. Remember, that's the slower rate. Now, since Rhapsody is slower, Spotify is faster by this much, we'll say the other rate is X, which is Spotify's rate, plus the 120,000. Now, how many quarters did Rhapsody use in 11 years? Well, remember there's 4 quarters per year, so that's 44x. And for Spotify, that was 7 quarters. So we have 44 is number of quarters, 7 number of quarters, times what we're saying is the rate. Now here's where a chart comes in handy, and I took a look at this already, so I knew it was coming up. So we set it up like so. So there's the number of quarters for Rhapsody, that's the slower one. Spotify in 7 quarters, and there's the rate. So we take the number of users equal the number of users. 44x equals this. We solve it for x, and we get x is approximately this. Now a little later on we're going to do cost and revenue problems, which is actually something similar to what we're doing here. So for the Rhapsody, on average, acquired this many users per quarter. That's the slower one. while Spotify's rate was 142,000 plus users per quarter. So challenging. All right, let's go on to 13. Now in example 13, we're going to mix 87 octane with 93 octane to end up with something sort of in the middle, 89 octane. And you want to end up with 100,000 gallons. How much of each should you put together to get this range? Well, we're going to use that same technique. We're going to try to divide 100,000 into two parts. We're going to say part of it is X, and the other part is 100,000 minus X. And we're going to say that the X will be the 87 octane, and this other part will be the 93 octane. And we want to end up with a mixture of 89 octane. So our equation is, again, our total amount is 100,000. And the algebra plays a wonderful role here. We're going to think of this as 87% of X plus this now, which is 93% of 100,000 minus X is going to equal this. And actually they have it all here as well. So I would first get rid of all my decimals, multiply through, which is what they will do, and we will solve for X, and we get X is approximately this. Subtract this from 100,000 and we get the other, and those are our answers. Now, when it doesn't come out even, this is always a challenge, because how many decimals do you put into MATLAB? Because if you're just off by a little, they will count that wrong. But my promise to you is that I will give you credit if you're just off a little bit here, and you've rounded off not the same way they did. Yeah, our last lesson was 49 minutes, and I see we're down to 43. So that's a little benefit here. All right, we'll wrap this up.